looking at a graph you've never seen before to see if you can understand this. When we build a home, they have to dig down and build what are called footings. So even if you have no basement, they dug a cement column down and put it on a foot. And this is gravel at the base of the house and what's called weeping tile or drainage tile. Very often these days, the gravel is actually stacked quite a bit higher up the side of the house. So this provides drainage and this provides depth. And it must go below an area called the frost depth. If you don't dig your footings deep enough and any water gets under here and freezes, the water will expand and lift the house up. And that will destroy a home. It's not a minor amount of damage. Like your home will fall apart in a matter of a few years if that's not done. And you have to dig so deep the ground will never freeze. And the drainage is really important too. You want to keep any water away. Thermal contraction isn't the issue. As the ground freezes in the wintertime, the ground will contract and pull away from the house, and you will often find dirt like at the surface of your house. You may find some gravel that you found as a kid because as the ground pulls away, gravel falls in. That's all right. But if water gets in there, the water will expand, which is an entirely different phenomenon, and it will expand fast. You can hear it. If a house is not properly drained in midwinter, sometimes you can hear like a bang when the water expands. Now, this may look really complicated, but it isn't. Let's see what this is showing. This shows the subsurface temperature, not the surface temperature, but the temperature going down. Now, be very careful. This is 48 inches here. That's only about a meter. This is from a research scientist. This depth is going down to 14 meters. And these are showing the months of the year. So February's temperature, when they recorded through the ground, it went this way. But all that matters is this is the yearly swing. At the surface, the temperature went in this location to -5, and the maximum temperature they recorded in August, right? At depth, when you go all the way down, there's like nothing. Right? They didn't really record any. So what you're seeing is as you go deeper, what's the temperature swing? On the surface, the temperature swung between -5 and 25. By the time you get 6 meters deep, this is the lowest temperature here, and this is the highest temperature here. So the temperature swing is getting less, and that's what they call the annual envelope. So can you pick the depth below which the temperature never swings to zero? Under no circumstances are you worried about a temperature of 0 degrees ever being reached. And that would be the depth of your foundation. So how do we do that? Well, let's just read our graph off here. I'm going to take a line. Nothing's working very well for me tonight. You see, yep, there we go. And I'm going to find 0 degrees, and I'm going to go up, straight up. That's the last temperature of 0 degrees there, right? And if I go sideways, once we were below about 1.5 meters, this swinging back and forth never went to these temperatures. So this temperature range, there we go, out over here, these represent temperatures from 10 to 25. Well, at this depth, 10 meters below ground, you never got any of those temperatures. 10 meters below ground, you were trapped between this range here. So we're getting the frost-free depth is anything below about 1.5 meters. Well, that's basically this. So this is how we determine the depth that we have to dig our footings to in any area. You measure the temperature at depth from winter to summer, and you find the depth at which no frost can occur. And you can apply mathematical formulas to this. And this is what I was doing in the Arctic, and I came up with a different way of modeling temperature at depth. So it's a really neat feature that scientists use, but it's also used in the building industry.